So now that we have a good understanding of what permissions are, now we're going to look into how we would actually manage and change permissions on files and directories. And the command that we're going to use for that is called, well, it's pronounced chmod, but it's really just short for change mode. And in Linux, you can kind of think of the word mode and permissions as kind of the same thing. If you're changing the mode of a file, it's pretty much the same as changing the permissions on a file. But before we actually get into using the chmod command to manage permissions on files and directories, first we're going to kind of talk through and explain the octal method of managing permissions on files and directories versus the symbolic method. So as I said before, the chmod command basically means change mode. And we talked before how there's basically three different permissions, right? There's read, there's write, and there's execute. And in previous classes, if you're familiar with counting in binary, we know that we count in binary from right to left in powers of 2. So we start with 1, then we go to 2, and then we go to 4. And so the way that we represent these read, write, execute permissions for the user, the group, and other is using octal. And to derive the octal number for each set of permissions, basically you just count in binary. Now we're going to break it down here, but after a while, you really will just get familiar with knowing exactly what octal numbers relate to which permissions. So for instance, if we were trying to set, let's go through all the different combinations of permissions that we can get using read, write, and execute. So if we have a 0, 0, and a 1 in binary here, that value is going to equal 1. And if we match these permissions up with each number, we can see that 1 is basically execute. So that would equal no read, no write, but execute. 0, 1, 0. That is equivalent to 2, which equals no read, yes write, no execute. 0, 1, 1. That is the decimal number 3, which equals no read, yes write, and yes execute. Now we need the number 4. For the number 4, we have a 1 here. 0, 0. That is the number 4. And that equals read, no write, no execute. 5 would be 1 here in the 4's place, 0 in the 2's place, and a 1 here. That is 5, which equals read, no write, yes execute. 6 would be 1 in the 4, plus 2 is 6, nothing in the 1's place, and that would be read, write, no execute. And 7 would be our highest number with a 1 in all 3 places. That is a 7, which equals read, write, and execute. So hopefully this isn't that confusing if you're familiar with basic counting in binary. But what we do is we basically use this binary counting method to derive at an octal number. So one of these numbers here is used to actually set the permissions using chmod. So for instance, if we wanted to set the permissions for the user to read, write, execute, well, read, write, execute is 7. So we would say chmod seven, and say the group permissions, we wanted to set the group permissions to just read and execute. So read and execute is 5 in octal. And then say we didn't want to give any permissions to other. So no permissions, we didn't really write it on here, but I'm sure you could assume that 0 is equal to nothing, nothing, nothing. So 750 would be equivalent to read, write, and execute permissions for the user. 5 would be equivalent to read and execute for the group. And 0 would be equivalent to no permissions for other. And then here we would just put like our file name. And that's how we would change the permissions on a file or directory using the octal method using chmod. Now the symbolic method is a lot more easier, but both have their uses. So let's look at, let me get rid of some of this here. Okay, so the symbolic method you can use basically is like this. You started off with either a U for the user, a G for the group, or O for other, or a for all, which means user, group, and other. And then for the permissions, well, then we have an arithmetic sign in the middle, and that arithmetic sign can be either plus, minus, or equal to. And this basically means add the permission, remove the permission, or set the permission equal to. And then we put the permission of either read, write, or execute. And so to show you kind of an example here, we could say chmod, let's say user plus execute / file. And what that would do is that would add the execute permission just for the user to / file. Now let's say we said G minus W, that would remove the write permission. If we said O equals tac, 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 that would essentially set it to where O or other had no permissions whatsoever. Let's say if you ever do basically just say chmod plus X, which you'll see people do quite often, what that does is that basically is equivalent to saying A plus X, which is all user, user group, and other at execute. So you don't really have to use the A ever. If you don't put anything before the arithmetic sign, it assumes A. So just be careful when you're doing that. If you just do chmod plus X on a file, you just gave everyone on the whole system the ability to execute that file, which may not be what your intention was. And a lot of people use that as a shortcut sometimes. So this can be a little easier sometimes. What's useful about the octal method is that, say you wanted to set the user permissions to, read, write, execute, and the group permissions to, just read, execute, and other with no permissions. You would either have to write 3 different commands in order to do that with the symbolic method, like we did here. Let's say that, let's say we wanted to do u plus, read, write, execute, and then, or let's say we wanted to do it equal to group, we wanted to do equal to read and execute, and other we wanted to do equal to nothing. So we would have to run this command either 3 times like this, or I believe there's actually some options that you can use in order to do all 3 of these in one command. You'd have to look at the man page to kind of figure out exactly how to structure that, but I think it is possible. Regardless, whether you did 3 individual commands in order to set all these permissions on a file, or you used them all in one command, it's still a lot more cumbersome than just writing chmod 750 on a file. So that is where sometimes the octal method can come in handy, is when you need to set all the permissions for user group and other to something very specific. The symbolic method is really useful when you're just needing to add like one individual permission for either user group or other, or you just want to remove a permission, just one permission or something like that from user group or other. It really just depends on exactly how you want to use it. But that is both the symbolic and the octal method of using chmod. Now we're going to go in and look at actually using the command a little bit more on the system. So in this demo, I'm going to be using the sleep command. The sleep command does exactly what it sounds like, absolutely nothing. It just sleeps. So you say the word sleep, and then after it you give an argument of a number, and it will sleep for that amount of time. So sleep 10 will sleep for 10 seconds, and then once it's done, you'll notice that my command prompt does not return to me because that process is currently executing. Once it's finished executing, my command prompt returns to me. So as long as a process is running here, what's happening is we're currently in the bash shell. And if we look at a PS, we can see that we are in the bash shell. The bash shell that we're currently in has a PID of 14846. And what it's doing when I run the sleep command is the bash shell forks off, effectively cloning itself, another copy of the bash shell, to a child process of the PID 14846. It then replaces itself with the code inside of the sleep command. Then the sleep command will run, and the parent process 14846 is going to wait until that child process is finished doing whatever it needs to do, and when it exits, it should reply or return with some sort of exit status or signal that tells the parent process that it is done executing whatever it was executing, and now the parent process can continue doing what it was doing. So what you're seeing here when we run sleep is that now, and if you try and type another command, let me sleep it a little longer, so sleep 5, If you try and type another command, it doesn't